So let us begin. So it's a common experience that an object feels lighter and weighs less in a liquid than it does in air, right? So when you put the same object in air and in water, you'll feel it very lighter when it is in a liquid, right? You can observe your even your body parts. When you immerse in water, you'll feel it lighter, right? Such observations suggest that a fluid exerts an upward force on a body immersed in it. That is the reason. The fluid exerts an upward force against the weight of the body which is acting downwards. Right? So that force creates that feeling of lighter. The tendency for an immersed body to be lifted up in the fluid due to an upward force opposite to action of gravity is known as buoyancy. So that upward force exerted by the liquid on the immersed body is termed as buoyant force, and that tendency is termed as buoyancy. That upward force by the fluid to an immersed body is termed as upthrust or buoyant force or force of buoyancy, that is always acting against the gravity. And the tendency of the body to be lifted up in an immersed condition when you immerse it in a liquid is termed as buoyancy. I hope it is clear. Buoyancy and buoyant force. The buoyant force is caused by the increase of pressure in a fluid with depth. That is already studied. We have discussed, and you know well that when you go down in a liquid, the pressure increases. So buoyant force is caused by that principle of increase of pressure in a fluid with depth. So buoyancy is due to the fluid displaced by the body. So when you immerse a solid substance in a liquid or a fluid, what will happen? An equivalent amount of fluid will be displaced from that location. The amount of fluid displaced will be equal to the volume of the fluid. Volume of the body, immersed body, right? That is, using that expression, we can write down the buoyant force Fb is equal to rho F. F stands for fluid, G acceleration due to gravity, V is the volume, rho is the density, mass density. So buoyant force is expressed by the simple expression rho F GV. We'll come back to that later. So please understand, buoyant force is always acting in the upward direction. You see here. Here there is a body immersed in a tank of some fluid, liquid, right? A portion of the body is inside the fluid and portion of the body is outside the fluid. Portion of the body outside the fluid is ABCA, which is inside the fluid is ADCA. ADCA is inside the fluid and ABCA is outside the fluid, right? So this volume, that is VF, VD is the volume displaced. D stands for displaced volume or submerged volume. So this much amount of volume, which is equivalent to the volume of the solid which is inside the liquid, right? That will be displaced. So volume displaced will be dependent on the submerged portion of the solid which is immersed. So Fb is equal to gamma into Vd. What is gamma? Which is weight density. What is weight density? Density multiplied with specific gravity. Acceleration due to gravity. Rho g. Gamma is nothing other than rho multiplied with g. So rho g into v. That's what we are seeing here. Rho f into g into v. So here a more clear expression is written, Fb is equal to rho g into Vd. Rho always, in the case of buoyant force, rho should be taken that of the fluid. G is a specific, gamma is the specific weight of the fluid and Vd is the volume of the body. Here this is not G, this is gamma. Please correct it when you are noting down this expression. Gamma is specific weight or weight density. Vd is the volume of the body which is inside the water or liquid or fluid, whichever it is. Now this buoyancy is based on this principle. You might have heard about this scientist Archimedes. The buoyant force acting on a body immersed in a fluid, that is, whenever a body is immersed, you know that there will be an upward lifting force acting on the body. That force is equal to the weight of the fluid displaced by the body. So when you immerse a body, an equivalent volume will be displaced. Here Archimedes told that weight of that amount of magnitude of the force is equal to the weight of the fluid displaced by the body. Unit of the force is Newton, unit of weight is also Newton. So there is no doubt about that, right? And it acts upward through the centroid of the displaced volume. The point of action of that force will be through the centroid of the center of gravity of the displaced volume. Not through the center of the entire body, but through the centroid of the displaced volume. This is the statement of Archimedes principle. Please have a look at it. Please note it down. You might have already studied this in your school classes. So we are interested in knowing how much will be the force acting when we immerse a body into a fluid and where that force will be acting. Through which line of action, the line of action or point of application of that force. These two things are important for us. Now that point of application of the force of buoyancy on the body is known as center of buoyancy. The point of application of the force of buoyancy on the body is known as center of buoyancy. Please note that it is always the center of gravity of the displaced volume of the fluid. Displaced volume. Always it will be center of gravity of the fluid displaced. Now you see here, there are three spherical objects. Three spherical objects or the same object at three different conditions, depending on the density of the relative densities of the fluid and the body. Now here the first case, it is a floating body where the density of the body is less than that of the fluid, rho. Density of the body is less than that of the fluid, it will be obviously floating. When it is equal to the density of the fluid, when the density of the body is equal to density of the fluid, it will be in a suspended condition, neutrally buoyant. It will not immerse or it will not float, neither completely submerged nor float. The last case, when the density of the body is greater than the density of the fluid, what will happen? It will sink. It will sink to the bottom of the vessel containing the fluid. When the density is greater than the density of the body is greater than the density of the fluid, it will sink to the bottom of the vessel containing the fluid. Right? So these are the three cases. These three scenarios possible by the relative magnitudes of the densities of the body and the fluid. So we can have the three different conditions: floating body, neutrally buoyant, and sinking body. Now, based on that, we can analyze the equilibrium condition of the three cases: stable, unstable, and neutral equilibrium of the floating bodies. These are the three different types of equilibrium of floating bodies. So here you see there is a stable condition, right? if you move this body towards this side or this side, it will come back to the original position after some time. Here, if you see, if you slightly move this towards right or left, it will move from its stable position. That is unstable, quite unstable. This is neutrally stable. If you move, it will attain a new position, new stable position. Right? Hope you understood the differences. Here it is stable, unstable, it will completely move. Here it will attain a new stable position when you apply some force. So this is similar to the buoyancy condition of the floating or submerged bodies. So we will analyze that stability of immersed bodies. When you immerse a body in a liquid or fluid, how we will say whether it is in stable, unstable or neutral equilibrium. You see here, for that you need to determine the position of buoyancy relative to the position of center of gravity of the immersed body. Stable condition, the first one. This pink color represents the fluid. Okay, pink color represents the fluid. W stands for the weight of the body acting downwards. FB stands for the buoyant force acting upward direction. B stands for center of buoyancy, point of application of FB. G stands for center of gravity, point of application of weight. Okay. Now the first case, in the case of stable body, G will be below B. That is, center of gravity or the weight of the body will be acting at a location lower than that of B, center of buoyancy. In that case, the body will be in stable condition. When G and B are coinciding, we can say it is neutrally stable. The immersed body is neutrally stable. When G is above B, the center of gravity is above B, the immersed body is in quite unstable condition. If you give a slight tilt, it will move from its stable condition. It can't restore its stable condition further. It is not possible for an unstable when the G, the center of gravity, is at a location above than that of the B. So these are the three different scenarios of immersed bodies to analyze the stability. So a measure of stability for floating bodies is the metacentric height. We will be discussing that in the next class. So stability for floating bodies is measured by a term known as metacentric height, denoted by Gm. You know what is G now? Center of gravity. What is M? That is a new term, metacenter. Distance between center of gravity and metacenter is a measure of the stability of floating bodies. So metacenter M is the intersection point of the lines of action of the buoyant force through the body before and after rotation. We will see that in detail later. So for now, please understand what is buoyancy and buoyant force and how an immersed body can be stable. That is only when G is below B. When the center of gravity is below center of buoyancy, the body is said to be in stable condition. This is very important in the case of designing a ship or boats or even aeroplanes which is moving in a fluid air. So we will stop for today. We will continue tomorrow with the measure of stability, metacentric height. How to find out metacentric height? We will be solving simple problems, direct simple problems on all these, on center of pressure, total pressure, buoyancy, buoyant force, then further metacentric height. So once we complete the metacentric height, that is in the next coming class, we'll finish the theory topics for the first module. Then we have to solve some problems on that. With that, we will wind up the first module. So at the end of the first module, again you can expect another quiz similar to what we have conducted earlier. Most probably some problematic questions we can expect. So start preparation now itself. Please stay active, refer to all the notes as well as the PowerPoint presentations and videos, whatever is available in the college website, as well as whatever I have shared. So at the end of first module, we can expect another quiz. Okay. Thank you for watching. Have a great day.